Hello everyone, welcome back to another episode. Today we are going to be doing the hot air balloon problem. Now this is a problem that actually showed up on one of my exams when I was taking my first physics course. So this one may be important to you. This is a great practice problem for kinematics, and it's going to be similar to the one we did in the previous episode where we're going to be doing two phases. So basically what's happening in this scenario is we've got this hot air balloon, and it's moving up at a speed of 5 meters a second. And this person is going to release this sandbag that they're holding, and we are set out to find how much time it takes for it to hit the ground, what the impact velocity is, and the max height that it reaches. So let's get right into it. So first, it's important to draw your pictures. So here we are in phase one, where the hot air balloon is going to be started right here. And at the second that he drops the bag, it's going to have a path that looks something like this. Just like that. And for phase one, what we're concerned about is we want to deal with the first phase, as I call it, where it is here. And at that particular instant, the velocity is 0. So we're going to deal with just this first part right here. Just this portion. So let's get into that. We know that our initial height is 40 meters. They gave us that. Our final height is, we don't know. Our final velocity, we do know, is 0 meters per second. Our initial velocity is 5 meters per second upwards. So let's draw that just so when we look back, we can see what we were thinking. That's the initial velocity because that is the initial velocity of the hot air balloon. It's going up 5 meters a second, so the initial velocity of the sandbag is going to be up 5 meters a second right in here. Okay. And we know the acceleration due to gravity is negative 9.81 meters per second squared. And time, we don't know. So let's go into the short and the long equations. I always like to start with the long, so we're going to do that. Y minus y naught is equal to v y naught t plus 1/2 a y t squared. Now let's see what we know here. We don't know final y. We do know initial y. That's 40. The initial velocity in the y direction is 5 meters per second. And acceleration due to gravity is negative 9.81 meters per second squared. So plugging all these values in red, we've got, and I'm going to add this 40 over, so we've got y is equal to 40 plus 5t minus 4.905 t squared, because 1/2 times negative 9.81 is negative 4.905. Okay, well, we don't know y and we don't know t, so we're going to move on to the short equation, which is final velocity minus initial is equal to acceleration times time, which is equal to negative 9.81 t. Now, we know that the final velocity is 0, according to here in our picture, and we know the initial velocity is 5 meters a second upwards, so it's positive. And we know that acceleration is this negative 9.81, so we've got negative 5 is equal to negative 9.81 t, and that gives us a solution of t is equal to 0.510 seconds. Okay, that's helpful. Now let's take that time, let's take that time, and we're going to plug that in right into here for t squared here, for t there, and we're going to solve for y. So our final max height is going to be 41.27 meters. And all we did here is we plugged in this into this equation here for t squared t, and it gives us this, 41.27 meters. Now, it turns out that's one of the questions that they asked us. They said, what is the max height? Well, that is the max height. The max height is where the velocity is equal to 0, and that's what we just told our equations to do. We told our equations that our object is stopped here at this instant, and that allows us to get the answer of this 41.27, which is actually the max height. So we can answer question C. We can say y max is equal to 41.27 meters. Cool. Now let's keep in mind these things because we're going to be using them in phase 2. All right, so phase 2, I've already went ahead and wrote our initial y distance because our initial y distance for phase 2 is going to be at the max right here when the sandbag is there. And at this point in phase 2, we're just going to be going down. Okay, so let's plot some of our velocity vectors. We know that velocity, the y direction initial, is equal to 0 because it's stopped. And then we have this impact velocity of, well, we don't know. We do know our initial y distance. Here it is. And we know that y final is going to be here at 0. So let's plug these things in. We've got y naught is equal to 41.27 meters. Y final is going to be 0 meters. The initial velocity is 0 meters per second. The final velocity, we don't know. Acceleration is negative 9.81 meters per second squared. And time, we don't know. All right, so let's do the short and long equation again. For phase 2, though. So we've got y minus y naught is equal to vy naught t plus 1/2 a y t squared. All right, plug in what we know. Y final is 0. Y initial is 41.27 meters. The initial velocity is 0. We don't know time. Acceleration is negative 9.81 meters per second squared. So plugging all this in, we get negative 41.27 is equal to negative 9.81 t squared. And solving for t, we get 2.90 seconds. Don't forget, this term is squared. So when you get your answer, don't forget to do the square root thing. So boom. All right. And then now let's go to the short equation to find the impact velocity. Here, we're going to find the impact velocity. So we've got impact velocity or final velocity in the y direction minus the initial is equal to acceleration times time, which is equal to negative 9.81 meters per second squared times time. All right, and we know that the initial is 0. And so we've got final velocity is equal to negative 9.81 times time. And we know that time is right there, 2.90. So that gives us the impact velocity of negative 28.46 meters per second. Sorry, my handwriting got a little messy right there, but that's just an M. All right. And I think that answers question B. Boom. And now let's go back and look at what they're asking. How much time until the bag hits the ground? Okay, well, believe it or not, we have all of that information because we have the time here from phase 1 when it's on its way up. When the sandbag is traveling on its way up, we have that time here. And then when it's at the top and going down all the way through its whole path, the rest of the path is in phase 2, so all we need to do is take the time that it takes to get to the top and add it to the time that it takes to get to the bottom. So let's do that here. Let's call this T1, let's call this T2, and we can say total time is equal to T1 plus T2, which is equal to 3.41 seconds. Sweet. That's C. And that's it for this problem. I hope this was helpful. If you enjoyed it or this got you the right answer, then feel free to give it a thumbs up. Leave a comment down below if you have any suggestions or any questions. I'll be sure to get back to you on that. And I'll see you next time. Thanks.